Alrighty, folks, we're looking at section 3.2 today, which is just continuing on with trigonometry, only we are going to be adding in a couple of other ratios besides tangent. And as you can see here, one of them starts with an S, the other one starts with a C, and it's not sin, but it's actually sine. And the one that's next to it is cosine. So sine, cosine, and tangent are the three trig ratios that we use for right triangles. And the ratios all involve sides that are opposite, the adjacent side, or the one we haven't talked about yet, the hypotenuse. And that's what the H stands for in each of these abbreviations. And so, we already know that tangent is the opposite side divided by the adjacent side. In other words, TOA, T-O-A. Tangent is opposite over adjacent. Likewise, sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. It's a little hard to kind of read it vertically like that, so let's just write it out a slightly different way for you. So, talking about a right triangle, obviously, and looking at the angle there, theta, the sine ratio for theta is going to be the opposite side over the hypotenuse. So there's nothing really too crazy new there, but just a slightly different set of sides, but it's still just a ratio of sides. And I could do a similar one for the cosine of theta. The cosine of theta is at CAH would be the adjacent side over the hypotenuse. And so there is your sine and cosine ratios. So nothing really new again, it's just a different way of ordering the ratios. But this little mnemonic here, SOHCAHTOA, if you remember SOHCAHTOA, you can remember all the different sine ratios, all the different trig ratios rather. Sine is opposite over hypotenuse, that's so. Ka is cosine is adjacent over hypotenuse. TOA, we know now, is tangent is opposite over adjacent. It's always going to be one of those three. Okay, so let's look at an example here and see if we can figure out what's going on. Okay, well here is our friend, the 30, 60, 90 triangle, and I've given you two sides there. What I would like you to do is just quickly pause the video for me, and what I want you to write down is what is the sine ratio for angle B? Angle B is right here, the 30 degrees. Okay, what is the sine ratio for angle B? Remember, it's opposite over hypotenuse. Write that fraction out and do the same thing for sine of 60. Or, yeah, sine of A, cosine of A, cosine of A. Sorry about that. Yeah, so sine B and cosine A. Sine of 30, cosine of 60. Write it out using the two numbers there. Okay, so for sine B, that's opposite over hypotenuse. Okay, so sine B, there's the opposite side here, 4. So it's 4 over the hypotenuse, which is 8. 4 over 8, or 0.5. Okay, for cosine of A, it's going to be the adjacent side. Here's angle A here. 4 is the adjacent side. The hypotenuse is 8. It's also 0.5. Okay, and on your calculator, if you were to type in sine 30, it would be the same as cosine 60, and they both equal 0.5. Okay, so it works just like the tangent ratio. The only difference is that sine and cosine is always going to be between, I believe it's between 0 and 1 for us in Math 10. So, but everything else works exactly the same. That means finding a missing side is the same, finding a missing angle is the same. Let's look at an example where you can find a missing side. Okay, well, I tell you what, I'm just going to have you pause the video here. I want you to try to write a ratio involving 50 degrees, the 4, and the x. Ask yourself, what side is the 4? What side is the x? Which ratio are you going to use? You have 3 seconds. Okay, well, the 50-degree angle is right next to the 4, so that means the 4 is the adjacent side. And the x is obviously the hypotenuse. So adjacent and hypotenuse, if we go back to our SOHCAHTOA, adjacent and hypotenuse means cosine. So you're going to write the cosine of 50 is equal to the adjacent side over x. Okay? Now, the same option is available here. I could have looked at 40 degrees over here, which that would have been, and I could have also said that sine of 40 degrees is also equal to 4 over x, but they're just as difficult to solve. It doesn't really help you at all in this case, so you pick either one. Let's just go with the cosine because that seems to make the most sense, the least amount of work. Okay, cosine of 50 degrees is equal to 4 over x. So to solve x, you're just going to switch the x and the cosine 50. Okay, and on your calculator, figure that out. Okay, and it's 6.2. So nothing's really different, just which ratio you're using changes a little bit. It's involving the hypotenuse now, but everything else stays the same. Okay, so what I want you to do is I want you to try this next problem here and bring it to class, and that will conclude the video for today. Okay, alrighty folks, here is your practice problem. Right triangle with 25-degree small angle there, and the opposite side, oops, I just gave away part of the answer. Opposite side there is 11, and you're trying to find the hypotenuse. Opposite side, hypotenuse, what does that sound like? All right, folks, bring that to school tomorrow. We'll go over it, and I'll make sure I give you marks for it. Talk to you then. Bye-bye.